So the title of our talk, we're talking about operationalizing BloodHound's attack graph for defense. My name is Andy Robbins. This is Rohan Vazirker. A little bit of information about myself. That's me like 3 haircuts ago. And it was also a very long period of time in Seattle without the sun, so a little more pale in that picture too. My official title, I'm the Adversary Resilience Lead at Spectre Ops. So what that means is that we go into an Active Directory environment and we help them harden their environment so that it's resilient against an adversary from getting access in the environment and being able to just laterally move wherever they want, et cetera, et cetera, et cetera. So BloodHound co-creator and developer. Historically, I've come from a red team and pen test background. Given talks at Black Hat, DEF CON, Echo Party, various B-Sides conferences, and then given training for red teaming at Black Hat USA and Black Hat Europe.
And that's me up there. That picture was taken when I first started Spectre Ops, and I was happy before Andy became my boss. I'm basically Andy's lackey. I just do whatever he tells me to.
For now.
Yeah, he makes me write lots of code when I know when to. I'm also the co-creator of BloodHound. I've presented at a few different conferences, nothing really important. I've done some training at Black Hat. That's always fun. So.
And then the third person of the BloodHound gang, as it were, is Will Schroeder, also known as Harmjoy. So he created PowerView, which is an Active Directory reconnaissance framework that was originally used to collect data for the BloodHound database. So here's our agenda. Here's what we're going to take you through. Some background and some prior work acknowledgments. We'll talk about data collection and architecture. Then we're going to do a case study and look at how we can use a methodology to isolate domain admins using statistics and empirical analysis. If we have time, we have a showcase of other defensive analytics that we can show you as well. And then a conclusion at the end. All right, so background and prior work. So I guess Darren asked the question earlier if people had heard of the BloodHound tool. Can we just see like a quick show of hands again, like who's heard of this tool? And who has not? Who has not heard of this tool? Okay, fantastic.
Who's actually used it?
Okay. All right, awesome. It's not bad. Okay, cool. So we're going to show the BloodHound interface for those of you who have not heard of it and kind of explain why we created it as well. But first of all, some important prior work. Microsoft actually created something, in concept, they created something that was very similar to BloodHound back in 2008 called HeatRay. There's a fantastic white paper there that you can learn all about that and how that works. Unfortunately, at the end of Raiders of the Lost Ark, like they took the Ark of the Covenant and they put it in this basement that's full of like all kinds of historical artifacts and all that. That's what happened to HeatRay, basically. It's in a basement in Redmond, Washington somewhere. PowerView by Will Schroeder, obviously, for AD reconnaissance. There's also a very similar project that came out before BloodHound called Active Directory Control Paths, which was created by 2 French guys, Emmanuel Gras and Lucas Boyot. And then finally, everything that Sean Metcalf has ever written on adsecurity.org. I remember when we first presented BloodHound at DEF CON 2.5 years ago, Sean was in the front row watching our talk. And then afterwards, we were hanging out, and somebody came up and said, yeah, so I want to know, how do I secure my Active Directory? Like, all right, first thing you got to do, read everything that you can on this website, adsecurity.org. And then you'll pretty much be good, probably. But in all seriousness, we've learned a great deal. Probably like half of what I know or more about Active Directory comes from Sean. So maybe we can just like acknowledge Sean's work. Yeah. Thanks. Thank you, Sean.
Also, when Andy says front row, he really means front row because Sean made his own row.
Yeah.
So.
All right. And it also feels like no talk is complete without this quote from John Lambert. So he said in a blog post that defenders think in lists, attackers think in graphs. As long as this is true, attackers win. I would highly recommend that you go read John's post about this. It came out in like 2014 or 2015, something like that. Fantastic blog post, and this is basically the mantra for how we think nowadays. All right. So I want to kind of tell the story about how BloodHound came to be. Like I said, we come from a red team and pen test background. And so back in about 2009, 2010, we and a whole bunch of other pen testers came to the same conclusion that Microsoft was getting a lot better at putting out secure code. So like remote code execution in SMB or DNS or DHCP started to become extremely rare. So you could no longer just drop into a network and throw MSO 8067 around and call it a day. Things became a little more complicated than that. But the nature of Active Directory means that it's, as everybody in this room knows, extremely complicated. People inherit Active Directory from predecessors who didn't really care about security or understand things like Kerberos delegation or security group delegation and things like this. So the permissions and privileges that exist in Active Directory are very, very difficult to ascertain. So for a given user that exists in a directory, if I say, for this user, what privileges do they actually have? There's nothing natively in Active Directory that can tell you that. So on the pen test side, or the red team side, if we drop into a network, we phish somebody, we get access to a system and a user credential for Active Directory, we basically had no idea what privileges that user had. Maybe we look at the output of net user whack domain for that user, and we see, okay, they're in the domain admins group, fantastic. Or maybe they're in the server admins group or something like that. More often than not, a domain admin is not the one that's clicking on our phish and giving us access initially.
Except when they are.
Yeah, sometimes they do, to be fair. To be fair, sometimes they do. So this methodology called derivative local admin or the identity snowball attack or the credential shuffle, there are several different terms for it, but it all means the same thing, is we have access to one user, we scan the entire network and find out where that user's an admin, then we choose a system to pivot to, steal whatever credential exists on that system, repeat over and over and over and over. But that methodology, while it is very reliable, is extremely tedious, and you're operating from the pen test side with both hands tied behind your back, really, and you have very little situational awareness this whole time. So we knew from PowerView that we could collect all the information about who belongs to what security group, who has local admin rights on systems, who's logged on different systems in the network, and then later on, what are the abusable ACEs that exist on securable objects, and what GPO applies to what objects. We can take all that information and we can put it into a graph, and then we can find attack paths very, very easily. So I want to skip ahead real quick and just show you the interface for BloodHound, which is here. And what we're looking at is a little bit complicated, so let's look at something a little more simple. So this is the domain admins group that we're looking at in the BloodHound UI. The node labels and would see exactly who they are. What we can also do with BloodHound, so from the red team side, what we're always interested in is what system do I need to compromise or what user do I need to compromise in order to be able to get to DA. So if I right-click on any node in the BloodHound UI, I can say shortest path to here, which I think, is that what that says?
No, 2 up.
Oh, 2 up, right here. All right, thanks.
We're at a really bad angle if you couldn't tell.
Yeah. So what this is doing in the background is it's running the shortest path algorithm in the graph database against the domain admins group from every other node that exists in the database. And so the output of this query is here. And so this is all of the attack paths, well, not all of the attack paths, but all the shortest attack paths that exist from any other principal in the domain to the domain admins group. So if we take a look at this guy right here, so here's a computer. We can say, let's set that as a starting node, and we'll set domain admins as the ending node. And then, just like in Google Maps, you say, how do I get from point A to point B? And BloodHound tells you. So from the red team perspective, we can see that this computer has a user that's logged on. That should say has session right there.
Yeah.
So we all know Mimikatz. We all know the Windows token system. So if you're the system user on a computer, you own the users that are on that computer. And really, that's also true for whatever compensating controls you can put on that system. There are bypasses for device guard, for EDR, you name it. If you're the system user, you own the computer and you own everybody that's on it. So an attacker on this computer can just impersonate this user or steal their password. And then this user, what does that say right there? Member of. So that user belongs to this security group.
Yeah, that's another member of.
And that group belongs to this group. and that group, what does that say?
Generic all.
Generic all to the domain admins group. So this user, because he belongs to this group and because that group belongs to this group gives that user the ability to do anything they want to the domain admins group. So generic all is just a different way to say full control. So if I have full control of the domain admins group, I can just add myself to the domain admins. Yeah?
This would only happen, like this particular scenario, this only happens if they modify admin SD holder though, right? Because how would you get that group to be...
Yeah, so we...
Yeah,
we've seen it before. Let's just...
Well, no,
yeah.
I know for a fact that's a thing. I'm just curious.
Yes, you would need to modify admin SD holder because otherwise domain admin's ACL just gets overridden by that.
Yeah.
So you are correct in that. However,
people do it.
People do it all the time.
People do it, for sure.
People do it, and third-party installers do it too.
Yeah. Just to clarify, this is not a real environment, hence why it's testlab.local.
Yeah.
Because real environments tend to be a lot worse than this.
Yeah.
So
yeah, that's right.
This is actually a randomly generated data set that we just created using a script. There's a lot of stuff in here that's a little contrived, but I guarantee you that stuff we've seen in real environments is way, way worse.
Yeah. So one other thing I wanted to show you real quick. So this computer, I should have local admins right here. Explicit admins, I think that says 4. So this is similar to the output of what you would see from net local group administrators, but security groups have people that belong to them and they have groups that belong to them. So if we unroll that out, there's actually way more admins on that system than the output of net local group administrators would have you believe. And so these users, they belong to that group. What is that, domain admins, obviously. But you also have more complicated situations here as well. So this user belongs to this group, which belongs to this group, which is an admin on the computer. We can also look at the obverse of that. So for any given user that exists, we can see what privileges they have. So group membership, local admin rights. So this user, I think it has explicit admin on 2. Is that what that says? Or 0? 0. So the user itself doesn't belong to the local admin group on anything.
Can you just mirror your screen? Might be easier.
I'm almost done.
Oh, okay.
Yeah. But then this number right here, what does that say? Oh, okay, we're not going to click on that. So we use a free and open source graph rendering library, which unfortunately can't handle displaying that many nodes. But the point of this is that for any given user that exists in the directory, as long as you have a comprehensive data set, you have good representation of the environment in the database, we can tell you precisely what privilege any principal in the domain has. And we can also do attack path finding from any node to any other node. So that's basically BloodHound in a very, very small nutshell. Okay. Right, so back to the deck. Now, this is really the takeaway point of our entire talk, is that the practical application of graphs to offense has fundamentally changed how we approach our assessments. Doing this kind of derivative local admin methodology manually would take tons of time. It might take us 2 weeks, 3 weeks, 4 weeks. It may take us months to actually accomplish. But putting all the data into the BloodHound database, that data collection element can take like a half hour, and then the path finding is instantaneous. And then executing the attack path just takes 10 or 15 minutes. So from the offensive side, our methodology has totally changed. We also believe that the practical application of graphs will also have a similar effect on defense. So that's what we're going to try to explore in this talk. All right, we did that. All right, we're going to talk about data collection.
All right. So one of the biggest issues that people have with BloodHound is that you need to collect a lot of data. When I say a lot of data, we're talking LDAP data, local admin data from each computer, local group data from each computer. We actually wrote a collector called SharpHound, which is all written in C#, and it does all this for you. It's wonderful. There's no actual work you have to do anymore. You just run exe. But just a quick data architecture here. Wherever you're running your BloodHound data collector from, it talks to the domain controller on both LDAP and SMB and grabs a whole bunch of data. It asks who is part of what groups, what ACLs are applied to what objects. It pulls all this data down, writes it into a coherent JSON format, which just nicely slots into the UI, and the UI takes care of everything for you. By default, BloodHound will reach out to every single domain joined computer that is alive and well and responding to 445.
Is there a way to narrow that down?
There absolutely is. You can either do it by a list of computers, or you can filter it by OU. It's kind of like the world's your oyster. There are other ways we do data collection using like stealth collection. Obviously, we are red teamers, so we've had to avoid lots of nasty things like Microsoft ATA. Boo. So we've actually implemented a lot of things in there that compromise the data quality you get at the, not really expense, but like it makes you less likely to get caught. However, in our experience, very few people have the net flow monitoring necessary to catch this. If you see a computer on your network talking on 445 to every single other computer, there is a problem. I'm going to tell you that right now, and it's probably this. So, as I said before, we have a executable called BloodHound. In case anyone doesn't know, this is a free and open source project. Everything is on GitHub. You can get it today. You can get it tomorrow. You can get it yesterday, probably, if you can time travel. But the source code's available for this, so if you feel like auditing my code before you put it on your network, you can take out the agent I put in there. But you run these commands right here, and it spits out a couple zip files. Easy enough. Those zip files, you drag and drop them on the interface, and all your data is in the interface, ready to use in your graph library. Setting up Neo4j is the worst thing on the planet, so I'm not going to go into that. Andy's done some really nice guides for it, but if you decide to invest the time into this, it's going to take you probably 30 to 40 minutes tops to get everything up and running. This is not a long, drawn-out process, and this isn't something that you need to get budget approval for. I'm selling you this free product right now. I don't know if that makes any sense. Yeah, no, I'm not going that far. But yeah, so these two commands. The first one, taxc is a shortcut for a collection method. We have lots of different collection methods in BloodHound which tune what data it collects, but all, as it implies, does everything. This is like the shortest way you can do to get a lot of data. And then logged on is a privileged collection method, which uses an API call that requires local admin to collect really, really good session data. Session data is very ephemeral, so we always tell people if you're going to be running BloodHound from a defensive capability, you want to collect lots and lots of session data. The more session data you have, the better picture of your network you have. When you know where people are logging in, you know what your risk exposure is. So the second command there, session loop, will tell BloodHound to enter a loop where it just keeps collecting session data over and over and over and over again. And as we see, max loop time is 24 hours. 24 hours of session data is going to give you a really good picture of your network. This is the part that's a pitfall for many new users of BloodHound because session data is very, very ephemeral. I'm talking like it can be a matter of seconds. It's easy to miss. So collecting lots of session data is important to make sure you get a good view of your network.
Yeah, the only thing to add on to that is by default, all the data that you're collecting with BloodHound, you only need to be a domain user to collect all this info. The exception to this is with Windows 10
Anniversary.
Yeah, anniversary update 16.07. Yeah. So that changed the security descriptor on the SMB server. So you have to be a local admin by default to collect who are the local admins on a remote system.
It only took 15 years, but Microsoft finally got us.
Let's look at a case study of how we can apply a methodology to accomplish a very simple goal using the graph. And we're going to look at a very easy case study, which is domain admin isolation.
Yeah, a good question on
Yeah, please.
session
Yeah.
When you collect information about a session and then the session's gone the next time around, do you erase that data? Or is it
No. And the reason we don't is because in our experience, we found that if someone logs onto a box once, they're almost certainly going to log onto that box again. People are very habit-driven in the way they use networks. An IT admin who's administrating a single system is going to administrate that system over and over and over again. So if we are executing an attack path and we land on a system that no longer has that session, we just wait.
Yeah, you just sit on it.
You wait 24 hours and, hey, guess what? Bob from IT is back again and everything is happy and we move on.
Yeah.
So.
And we know precisely where to go after that to get to domain admin. Yeah.
So would this be a good tool to find out service accounts that absolutely no one knows anything about?
Oh, yeah.
Oh, totally. Yeah.
Actually, that has happened many times where we run an assessment and we show them, like, hey, check out this service account. And they're like, what service account?
Yeah.
And that leads to a whole other process where they scramble to figure out why this service account they thought they deleted 4 years ago is still logging onto every domain controller.
Yeah.
Not speaking from experience.
Yeah, good question. So this is the methodology that we use. We call this the Active Directory adversary resilience methodology. So it starts in the upper left, where we enumerate our attack paths. That's our data collection element. Then we analyze those attack paths, and we see what is the graph telling us as far as user behaviors, credential hygiene, ACLs, all that kind of stuff. Then we come up with and we test what we call resilience hypotheses. And these are basically saying, if I do this thing, then I'll reduce the number of attack paths by whatever percentage. So we test those in the graph before we deploy them in the environment to see, all right, how effective is this best practice actually going to be? Then we deploy those prioritized fixes and just repeat over and over and over. Okay. So these hypotheses, they're based on best practice and also on what the graph is telling us. We test the effectiveness in the graph. We review with the client and we say, all right, we think that this is a good idea that you should deploy in your environment. Can you actually do this? And let's have a conversation about that. And sometimes the answer is yes, we can do that. We can do that right now. Sometimes the answer is no, and they say, no, we have a legitimate business need to have this situation, and it's not going to change. So then we talk about maybe compensating controls, or we go back to the graph and we say, all right, they can't fix this one thing. Let's find a different fix that accomplishes the same goal, which is the last bullet point. All right, now a couple caveats. Domain admins are the most obvious target for adversaries and the most common thing. It's what everybody talks about, is everybody wants to be a domain admin. However, there are obviously several different principles that exist that give you equivalent or domain admin equivalent access in Active Directory. So, for example, if you are a local admin on a domain controller, you are a domain admin. If you are a backup operator, if you are in the account operators, Sean has, no surprise, Sean has a great blog post talking about all these different alternatives that give you the same amount of access the domain admin does, and he breaks it out and tells you precisely how that access can be abused to give you DA equivalent access, so to say. So this methodology, we're targeting the domain admin's node, but the graph, that's completely arbitrary. We can apply this to any principle that we want. It doesn't have to be just domain admin. It could be enterprise admin. It could be account operators. It could be backup operators. It doesn't matter.
It could be some system you store PII on that you want to make sure no one has access to except for 1 or 2 people.
Yeah.
The graph doesn't care where you're starting or where you're ending. If there's a path there, it'll find it.
It can also be more than one destination. So we can look at groups. We could look at tiers, etc. So we're going to look at protecting DAs from 3 different attacks: credential theft, object takeover, and takeover via GPO abuse. All of the GPO work that exists is thanks to Darren. And so Darren helped us a lot to understand how does GPO apply to objects and how does inheritance and all that kind of stuff work. So thanks a lot, Darren, for helping us hack people better.
For being the only person in the world who understands how GPO works.
Yeah.
Great. Technology could have done this.
So the first thing that we do is we make sure that we have really good data coverage. So we have several different quality assurance checks that we run to see, do we have 100% of user session data? Do we have 100% of the ACEs that can be abused? We do that. We make sure that we have good data coverage. Then we start generating some statistics. And so for this objective, this particular objective, what we care about is how many active users in the directory have an attack path that gets them to domain admin. And when we start, usually it's 100%, which is bad.
That's not made up, by the way.
That is not hyperbole.
100% real.
Yeah.
Just like the number.
Yeah. So we start analyzing these attack paths and trying to figure out, okay, why is this? If you have 100% of users with an attack path to domain admin, usually you can look at the domain users group and look at the attack path that goes to the domain admins group and start there. So that's exactly what this is. And over here on the left is the domain users group. The domain users group has been given RDP access to this computer right here, which we know there is a local privilege escalation opportunity on. So anybody can RDP to it and become a local admin. Then there are all these people here that log on to that system. So maybe this is like an IT jump box, or maybe it's an Exchange server. So all these users log on to that system. Then the attack path from there are many different options. We can either use group membership, or we can use an ACL attack path. The bottom line is that it gets us to domain admin, which is here at the right. Now, so you may look at this and you may think, okay, well, there's this common node right here where everything is going through. And so if I just get rid of these relationships right here, that should take care of it. Who thinks that'll take care of it based on my tone of voice? Nobody.
Anyone want to make a guess what that 100% goes down to? Wow, it's a good
100? Okay.
It's a good guess.
Yeah. Oh, please.
When someone can...
If there is a local privilege escalation on the box, then they are vulnerable. Having a local privilege escalation on the box is really a factor of how many third-party tools you have installed and how bad they do sanitation.
Yeah.
I would say on average, probably like 50% of the boxes we land on have some kind of privilege escalation if we need it.
Yeah. That doesn't require exploiting something.
Correct.
Just abusing a misconfiguration.
Or like a DLL hijack or something along those lines. It's not uncommon, but in this case, in this scenario, we know for a fact that there is a local privilege escalation. So we're just going to work off that.
Yep. So you're right. If we hypothesize and we say, okay, if I get rid of these relationships, it should have some reduction in the attack paths of domain admin. We can simulate that in the graph, and then we can regenerate our statistic, and we find out, oh, it's still 100%. We had literally no effect at all. But we can go back to the graph, and we can say, all right, well, what do the attack paths look like now? Okay, well, they're maybe a little bit longer, maybe a little bit more complicated, but they're still relatively straightforward. So again, domain users can RDP to a different system now, and there are different users logged onto that system, and the attack paths go from there. So if we follow one of these, this computer right here had a session for this user. This user is an admin on this computer. So just reading from left to right, I know that I need to pivot to this box, then steal this guy's credential, pivot to this box, steal this guy's credential. This guy belongs to this group, which can RDP to this system. So maybe there's a privs, maybe there's not. That guy's logged onto that system, and that guy's a domain admin. So in 3 computers, we get to domain admin, which is a relatively long attack path, actually. But the point of this, oh, also, if we get rid of everything here, it's still 100%. So the point of this is that if you go through this kind of whack-a-mole methodology, you're going to be infuriated because you're going to have very little effect. And the reason for this is that the graph is deceivingly actually very complicated. I like to say that the graph is kind of like the sun because you can't look directly at it. So a lot of times people ask us, how do I see all attack paths of domain admin? Well, you can't. And so anybody who knows anything about graphs knows that the number of relationships that you get can be an order of magnitude or more than the number of vertices that you have in the database or in the graph. So we may have like 100% of users, and that could be like 10,000 users that each have an attack path to domain admin. But if we tried to look at all the attack paths, there are going to be several different avenues or several different ways to go from domain user to domain admin, and it could be millions. And so going through this kind of whack-a-mole methodology, it's not going to work. So we have to be a little bit smarter about this. So what we can do instead, we can just take a look at the domain users group and find out what privileges does that group have. All right, so the domain users, they can RDP to these systems here. All right, so we talk to the client, and we say, does this need to be this way? Sometimes people say yes. But most of the time people say no, and they say, oh my God, I can't believe this happened. How did this happen? We didn't know about this. Yeah. So we work with them. We remove the group from the RDP group on the computers in the graph, and we simulate and we figure out what kind of effect is that going to have. And then we regenerate our statistic, and we find out, oh, now it's only 65% of users have an attack path to domain admin. So we're actually making some progress here.
Only 65%.
Yeah, still pretty bad.
No big deal.
Yeah. So if you have a 500,000 employee organization, that's math.
325,000?
Yeah, sure. It's
Something
65% of 500,000 people. Math is not my strong suit. But that's probably still an intolerable amount. It's probably too much risk for anybody to stand.
So the Citrix.
Yeah.
Right.
Yeah,
Citrix is a big offender
Yeah.
of this, actually.
Yeah.
I just wanted to make sure I was thinking correctly. Okay.
Yeah, that's usually the culprit when people don't want to remove domain users from the RDP group. Yeah, but I think depending on what version of Citrix it is, you don't actually need to have the users in the remote desktop users group on the the Citrix instance that gets stood up. But I could be wrong about that.
We're not Citrix experts,
Yeah.
unfortunately. Or fortunately, probably.
Yeah, probably fortunately. Yeah. So. Now that we're making some good progress on this, we're going to look at the other side of the attack paths, and we're going to look at our domain admins in particular. So if we look at some behavior of our domain admins and we see, what systems are they using? In the BloodHound interface, you can click on a group, and then you can click on sessions, and it'll show you all the computers that the members of that group are using, including if they belong to a group that's been added to the group. So all these computers here, this computer right here, they have sessions for domain admin users, including this guy right here who belongs to a group that was added to the domain admins group. Don't do this. This is really bad practice. So we talk to the client and we say, all right, your DAs are spraying their credentials all over the place. We think it'd be best practice if you restrict them to only logging on to domain controllers or PAWS or jump boxes, or systems that they're running ADUC on, etc. So we have that conversation, and we find out, okay, we can limit the domain admins to these following systems. All right? So these two DAs, they're only logging on to those systems from now on.
Is that through GPO? How do
It's up to you. There's several different ways to skin that cat. You can certainly do it through GPO, but lots of different ways you can deploy that. We try to figure out, based on the client's existing capabilities and the technologies they have, what works best for them.
So how evil is run as?
I'm sorry?
How evil is run as?
Run as? I guess it depends on the context.
Run ADUC as a domain admin.
Doing it from another system, I'm pretty sure puts those secondary logon credentials in memory.
Yeah.
So ideally, you want to do that run as from a domain controller or something along those lines.
Yeah.
Sometimes the solution to preventing people from logging on to other stuff is as simple as being like, don't log into other stuff.
Yeah.
And making your admins do that right. And it's a culture thing in a lot of places where, especially places we've seen where they don't have split accounts, for example, where they don't have a privileged account or regular account. People just use their privileged account for everything.
Yeah.
And that becomes a big problem.
Yeah.
So.
You guys see many customers implementing the Microsoft Tier 0, 1, 2 recommendation?
I've seen one.
Yeah, I've never seen it.
It's very, very, very rare.
Yeah.
And it's very, very
Yep.
difficult.
I'm leaning against it, but I was going to say that the first rule is remove domain admins from the local administrators group on every single machine except the domain controller.
Sure. Yeah, I've seen people do that. Yeah.
Yeah, I've seen that once, and I felt really bad for their admins, but
Yeah.
it probably worked.
Well, they should be administrating boxes using server admin accounts or workstation admin accounts.
They should
Sure,
be.
they should be.
And not using the same account for multiple workstations.
Sure. The great thing is that when you have all this data, you can see what they're actually doing. So, and you can demonstrate to them why they should not be doing the more dangerous things that they're doing, and preach to them using empirical evidence what the effect of using a better practice would actually be.
I'm also going to say there's a lot of things people should be doing in Active Directory, which they're definitely not doing in Active Directory. So that's like the tip of the iceberg there.
Yeah.
My understanding was that you're supposed to keep the domain admins in the administrators group across the domain, but then you're supposed to put in GPLs to deny logons and batch job on the server.
Sure.
Are you guys seeing that, or
No. No. I mean, I would say look at the SANS top 20. Who does any of that? hardly anybody. Like having a software inventory, I have seen a software inventory one time in my career. Like there's all this best practice that just nobody does. They should be doing it. In our experience, it's very rare that anybody actually follows any of that.
I'm sure there's a network somewhere that does all this stuff. I just haven't seen it.
Yeah, me either.
And I don't believe I'll see it in my lifetime. So,
Part of the challenge is doing that at scale.
yeah.
Yeah,
The tools aren't terribly useful.
totally. Yeah,
And I think the inheriting an environment also, like you said,
Yeah.
it's really hard to like, without starting over, know all of the places where things are misconfigured.
Yeah.
Obviously,
Yeah.
we're trying to solve that. But
yeah, right.
Have any of you
Yeah.
guys ever installed Outlook 2007 on your domain? Because if you have, you really want to run this.
Yeah, I wish you luck.
Outlook is one of the biggest offenders of overprivileging by far.
Yeah.
Was it 2000?
2007 before SP1.
Yeah, so
Exchange
if
server.
you've ever installed Exchange 2007 before SP1, the Exchange Trusted Subsystem has granted itself basically full control over every principal in the domain. So if you compromise an Exchange server, you have compromised the entire domain.
Yeah,
So just
you can DC sync
Just food for
with an
thought.
Exchange server. Yeah. Okay, so yeah, go ahead.
Does the tool distinguish between smart card sessions and using password sessions?
No, we just so when we do our data collection, we use the net session enum API call. So it's all network sessions like SMB share access. I don't even think RDP gets classified as a network session for some reason. The privilege method we use actually collects local logon data, but in our experience, smart cards make absolutely no difference to us. If we can compromise the system and we can get the NTLM hash of a user using a smart card, fun fact, a smart card NTLM never changes. So
Yes. So on the offensive side, we went into an environment. The reason we created the tool was for such an environment where they had Bastion hosts, like you said, and they also had a privileged access management system that protected the privileged accounts. It was the entire point of creating the tool was we would get to a system, we would compromise it, we would steal somebody's password, and it's changed, and also the user is disabled. And it took us 3 days to find out where that user was logged on. And how to get to them. And so we pulled our hair out for weeks trying to figure out how to operate in that environment. Then we created this. It took us like 20 minutes to find an attack path. And the privileged access management system, the users that had been checked out of that system and were logging on the environment, we knew that where they were logged on fast enough so that we could get to them, steal their credential, move on, etc. So yeah, that's the kind of environment that we created the tool for, and it was devastatingly effective. It was really, really good for us.
just as a side note, BloodHound doesn't care about domain trusts. It enumerates data locally on systems. We've executed attack paths using BloodHound that cross trusts for like
seven or eight
different domain trusts.
Yeah.
So taking us from some random domain in the middle of nowhere all the way up to like the forest root in like US proper or wherever it happens to be. Once the data is collected, the complexity of the graph doesn't matter.
Yeah.
We will find a path if it exists, and it's always executable. So
yeah, and pathfinding takes like 20 milliseconds, like regardless of how complicated the attack path is. So the complexity that's involved as far as finding the attack paths, we don't really care about. The graph handles that for us. So really, really good question. Okay.
You said you're using the Operation.
Yeah, that's right. That's right. Yeah, the community edition of it, so it's free to distribute and use. All right, so back to our little case study here. We're looking at the new situation. So the domain admins, they're only logging onto these computers. The great thing about a domain admin is you can bypass whatever security control you want. So there's some level of trust involved with deploying these kind of controls to DAs, and also auditing that you need to do. Which, if you want to find details about that, read adsecurity.org. So the bad part of this is that all these computers, they're going to have admins of their own. So if we expand this graph out to the left, we can see that over here we have our domain admins, we have our users, and we have the computers that they're only going to be using from now on. However, all of these principals to the left are all of the admins that have administrative access to those systems. So now, based on the credential hygiene for all these users, or based on the attack paths that exist against these users, that is what's going to translate into an attack path to a domain admin. So if we regenerate our statistic and find out how many active users still have a path to DA, before it was 65%. Now it is, anybody want to take a guess? That'd be bad.
If it goes back up, then something has gone seriously.
Yeah, 40%.
Okay.
64%. Okay, all right, okay. So it was 65 before, now it's 65 still. So we had basically no effect. Well, not necessarily no effect, but we still have a lot of work to do. So we want to look now at, so we looked at credential hygiene. We looked at local admin rights on systems that domain admins use. What we also want to look at is what ACLs apply to the domain admins group. Now, by default, the DACL from the admin SE holder object is what gets cloned off onto any principal that has admin count of 1 or that belongs to a group that has admin count of 1, including the domain admin users. You can change that. So you can set a principal or a user object or a group object or whatever to not inherit the admin SE holder object DACL. And we've seen people do that. But for the sake of argument, we'll just look at the domain admins group itself. So here's the domain admins group. Here's a group that has the ability to add members to that group. There is a group added to that group. This group right here is the Exchange Trusted Subsystem. These are all of the Exchange servers. So when you are the system user on a computer, you authenticate across the network using the computer account from Active Directory. And so you have all the same privileges that that computer account has in AD. So if I'm the system user on one of these systems, I can just add myself to the domain admins group, or I can add an arbitrary user to the domain admins group. We also have, this group has the ability to change the DACL on the domain admins group. This group has several different permissions. It can change the owner, it can change the DACL, it can generically write to any non-protected attribute on the object.
It's probably administrators.
It's probably the administrators group, yeah. So now we go to the client and we say, listen, this is really bad. Also, we know that the Exchange servers do not need this permission on the admin SE holder object. There are several different ways that we can come to that conclusion. One is that we can start collecting 4668 events from the DC, and we can compare the permissions that are actually used by a principal versus what the permissions that it has. What we can also do is look at the Exchange documentation and compare the version of Exchange that they're currently running versus the permissions that exist from the first version of Exchange that they installed, which when you upgrade Exchange, there is no cleanup process in the installation process. So the sins of 2007 exist now, 11 years later. But the documentation for the current version of Exchange tells you exactly what permissions it requires, and then we can just trim out whatever's not needed, including all this garbage. So we make these changes, and we also, it kind of makes sense that the domain admins should be the only ones that have the ability to do anything to their own group. So we basically trim it to that state so that only the domain admins can change the domain admins group. And again, remember, we're only focusing on that one group because it's an easy target. We can apply this to anything else. So now, we regenerate our statistics. So beforehand, 65% of active users had an attack path domain admin. We regenerate our stat, and now it's 15%. So this is something very interesting now. So we're making some really, really good progress, and we're like, I don't know, maybe 2 days into an assessment. So finally, we talked about credential hygiene. We talked about object takeover attacks. If you want to know more detail about how those attacks work, come talk to us after. We'll be happy to talk to you about that. But now, what we're going to talk about is GPO. Mm-hmm. So with BloodHound 1.4, 1.5?
That's right.
We added GPO and OU tree structure into the attack graph design. So for any user or computer object, you can see what are the GPOs that effectively apply to this. Or for any given GPO, you can say what are the computers and users that are affected by this GPO. So let's take a look at our domain admins again. Here's a domain admins group. Here are the users. Here's a group that was added to the domain admins group and 2 people that belong to that group. We can also see these users in the OU tree structure. So this is also something that is very, very typical, but it is not best practice. The domain admins exist all over the place in the OU tree. So here's the domain head right here. The domain contains this OU right here, which contains this OU right here, which contains this user. That user is a domain admin. There's also this OU right here, and then this other tree right here that contains domain admins. We've also seen people put domain admins directly onto the domain object, which is pretty dangerous for a lot of reasons. But what we can now do is run a query in the graph that says, what are the GPO that apply to the members of my domain admins group? So if you try to do this in Active Directory itself,
good luck.
You're not going to have a good time. Like, Darren can probably tell us like how to do it more effectively than we know how to do without a graph. But using the graph, we can easily visualize what this looks like instead. So all of these GPOs, they are linked directly to the domain head. The OU trees that go under this, none of them are blocking inheritance. So even though these GP links are not set to enforced, it doesn't really matter because they're going to be applied to those child objects. There are two caveats to that. One is WMI filters, and the other is SID filtering for a GPO. We don't collect that information, so we manually look in Active Directory for that when we're going through our analysis. But all of these GPOs, they're linked to the domain head. They're then applied to the users that belong to the domain admins group. Now, what we want to find out is, all right, for these GPOs, who has control of these GPOs that is not a domain admin? Sure, yeah, the group policy creator owner, maybe the administrators group. There can be several different possibilities. In this particular case, we had seen a good job of cleaning up things like that. So there was really only one, or actually there were 4 instances of where the domain admin group was not the only one that had control of all these GPOs. So we can run another query in the graph, which these queries that are running now, they're getting like this long. They're like really complicated. And that looks like this. So these four users, they belong to this group, which belongs to this group right here. This group owns these 5 GPOs that apply to the domain admin users. If you own an object, you retain the ability to change the security descriptor on that object. So if I'm the object owner, I can just grant myself whatever permission I want. And if I have control of a GPO, I can push down an evil policy, which Darren has really good write-ups about how you can do that on his blog, and then take over that user using, I mean, there's like 10,000 ways to do it. You can literally do anything you want with GPO. All right, so we changed that. Now we regenerate our stat about how many active users have an attack path to domain admin. And anybody want to take a guess? We were at 15% before. Now we're going to be at
10%.
10%? Anybody?
15%.
5%, 15%? Okay, so what we actually get to, drum roll please, is 1%. Actually, the real number was actually much lower than 1%, but we rounded up, you know. So put another way, we spent 2 weeks in this environment, and we provided actionable, practical, and highly customized suggestions based on existing capability and requirements to the client. We reduced the number of attack paths that existed, going from anything to domain admin to over 1 million to less than 1,000. We reduced that number of users with an attack path to DA from 100% to less than 1%. And then what we haven't talked about right now, but we may have time to talk about, is this concept of highlighting key terrain for what systems and users should be very highly monitored going forward. So
We'll come talk to you afterwards, though.